The blueprint for our entire digital world. I mean, for the very device you're watching this on right now. It wasn't drawn up in some garage in Silicon Valley. Nope, it was meticulously designed way back in the age of steam in Victorian London by a true visionary named Charles Babbage.
It's a pretty wild thought, isn't it? A steam-powered computer? But here's the thing, that's exactly what happened. This isn't some steampunk fantasy. It's the real story of a mind so far ahead of its time that honestly, the world is still trying to catch up.
And this quote, man, it gets right to the heart of the whole problem. See, back in Babbage's day, computers were actually people. Yeah, entire rooms full of them just crunching numbers for endless tables, for things like navigation and science. And while being human, they made mistakes, all the time. Babbage was so frustrated by these constant errors, he had this incredible idea. What if you could just automate the whole thing?
So his first monumental crack at solving this was something called the difference engine. And let's be clear, this wasn't some little pocket calculator. It was an absolutely audacious plan to build a machine that could mass-produce perfect mathematical tables flawlessly.
The idea behind the difference engine was just genius. Babbage used this really clever mathematical trick, the method of finite differences. It allowed the machine to solve incredibly complex equations using only addition. And addition is way easier to build a machine to do than multiplication or division. It was basically like he invented a software hack before software was even a thing.
And just look at the sheer scale of this thing. His first version was designed with around 25,000 parts. It was supposed to calculate things to an accuracy of 20 decimal places. But the project was just a mess. Babbage had a huge falling out with this chief engineer, the money dried up, and the government finally just pulled the plug. The first difference engine, it was never finished. A brilliant, tragic failure. Or so it seemed.
But, sometimes it's from the ashes of a failed project that something truly revolutionary emerges. Babbage had a realization. He wasn't just trying to build a better calculator anymore. He was on the verge of designing a machine that could actually be programmed to think.
And this right here was the massive conceptual leap. The difference engine was a specialist, It was built for one job and one job only. But the analytical engine? That was a universal machine. It could be programmed to do any calculation you could possibly think of. This was the birth of general-purpose computing as we know it.
And just look at how he laid it all out. He broke the machine down into 4 main parts. There was a store to hold the numbers, that's the memory. Then a mill to do the actual number crunching. An input system that used punched cards, an idea he borrowed from looms that wove complex patterns. And finally, an output system to print the results. Does any of that sound familiar?
Because it absolutely should. The mill, that's our CPU. The store, that's RAM. His punch cards were essentially the software. Over 100 years before the electronic age, Charles Babbage designed the fundamental architecture of every single computer, tablet, and phone we use today. That is just staggering. But wait, it gets even crazier. The analytical engine could do something we now call conditional branching. It could check a result and, based on that, choose a completely different set of instructions to follow. This ability to make decisions, what Babbage called the engine eating its own tail, is the very soul of software. It's what makes everything from your operating system to your favorite game possible.
So, Babbage's design was this incredible mechanical body, but it needed a spark, a soul. It took another brilliant mind to see its true potential and, get this, write the very first program for it. And her name was Ada Lovelace.
Ada was the daughter of the famous poet Lord Byron, and she was a mathematical genius in her own right. When she looked at Babbage's plans, she saw something more than just a number cruncher. She had this poetic insight. She realized the engine could manipulate any kind of symbol, not just numbers. It could handle musical notes or letters. It could weave information itself.
So while she was translating an article about the engine, she added her own massive set of notes. And in one of them, the now famous Note G, she wrote out a detailed step-by-step algorithm for the machine to calculate something called Bernoulli numbers. It is, by literally every definition, the world's first computer program. She wasn't just commenting on his work, she was the very first programmer. Okay, so this brings up a huge question, right? If these designs were so incredibly revolutionary and the world's first program had already been written for them, why did Babbage die with his machine still just a collection of blueprints and spare parts?
Well, a big part of the answer was the man himself. Babbage was a genius, no doubt, but he was also famously difficult to work with. He had all these public feuds, and he even had this bizarre, obsessive crusade against London's street musicians. That kind of stuff tends to make enemies, and it cost him the political and financial backing he so desperately needed.
And honestly, his mind was just too restless. I mean, the guy pioneered operations research, he broke his supposedly unbreakable military code, he helped reform the postal system, and he even cooked up this theology where God was basically a divine programmer. His genius was just too big, too broad for one era to handle.
So for decades after he died, Babbage was mostly remembered as a cautionary tale, this brilliant guy whose ambition just got the better of him. But that is not where the story ends, not by a long shot.
For more than 100 years, his incredible machines were just dismissed as these beautiful, complicated fantasies that were impossible to actually build. He was remembered as a brilliant failure.
Until 1991, 120 years after his death, that's when everything changed. A team at the London Science Museum decided to build his later, more refined difference engine number 2. And here's the kicker. They used only the materials and tools that Babbage would have had. And when they finally cranked the handle on this 7-ton monster of brass and steel, it worked. It worked perfectly. It calculated to 31 digits of accuracy without a single error. So it turns out the failure was never in his design. It was in the world's ability to keep up with his vision.
Babbage's story leaves us with this really powerful idea. A vision can be perfect even if the world isn't ready for it. And that really makes you wonder, doesn't it? Who are the Babbages of our time? Who's out there right now, drawing a blueprint for a future that we can't even see yet, let alone build?